Hello, hello, hello. Welcome to our next lesson of ratios and rates. This is from the Stage 4 Year 2 Maths curriculum. And we are looking at lesson number 6, sticking with the scale drawings, scale maps here. And we've got some work from the booklet to do. But first, I wanted to do some stuff with Google Maps, just showing you. I mentioned it last lesson. I just want to make sure that I show you how to use it. Now, obviously, you can just put into Google, how do I get from A to B? And it tells you exactly how many kilometers you are. But sometimes it's useful to be able to just know the scale of a map and automatically. So you don't have to constantly type up how far from A to B. So right now, we've got Tamworth here. We've got Peel High School here. And if you look down the bottom, I know it's small, it's there. I guess not many people care, but it is there, is a scale. So that tells you that distance there, which is on my screen, on my monitor, about 2 centimeters, but just seems a bit low. That's 200 meters. So when you're looking at everything, so from Peel there to there, 200, 200, 200, 200. It's just a rough guide to think about all the measurements you're seeing there. So but if we zoom in, look at what happens to the scale. So I'm here and I'm sliding over. Still, you slide left and right, the scale doesn't change. But as soon as I zoom in more on Peel High School, the scale is adapting. It went up 200, 200, and now it's saying 100 meters. So now 100 meters there. So from going across over from Peel to Caltex, according to that, from marker to marker, looks like about 300 meters from there to there. And from Peel, from marker down to this church, we got, which I didn't even know was there. Thank you, Google, for informing me about that. 1, 2, 3, 4. It's about 4 lots of 100 meters. So it's in a straight line, 400. But if you, of course, you can't do that. So you have to go from here, go 1, 2, 3, 4, 5, 6 by 2. So it's about 600 meter walk going along Gunnedah Road, then down into Ridge Street. So those scales there, you can always, on any map, they're going to have a scale on it. If it doesn't have a scale, it's just something that shouldn't be treated seriously, because only if it's got a scale do you know if it's done properly. I had a map once when I was hiking, and it was not to scale, and that was really bad, because it just said, oh yeah, just walk this a bit further and you'll be fine. And that little bit further on the map was actually hours and hours of walking. Same thing happened in Japan. I had a rough map showing the onsens, the spas in an area, and I was using that. I really shouldn't have, because it did not show the distances. I was walking for hours in the cold, in the snow, along this busy road. With not, oh my God. If I had a proper map, I would not have gone for that walk. I would not, because I would have seen just how far I was going to be going. And I had limited time. It's not like I was traveling for months and months. I didn't have long. So here we go. So this little bit of scale can help you out just to understand what you're looking at here. So when you look at the main street, 200 meters there. So between each road there, 200, 300, about 200 meters from intersection to intersection going down there. All right, hey, so that's Google Maps. I'll just get rid of that. And we're going to do some questions from this booklet here. I'll zoom in a bit. So scale drawings and maps. And they are expressed as ratios more commonly. And we're going to get into it. Before we get started, what we are going to need is this. So please write this down. How do you get from kilometers to meters? You times by. There are 1,000 meters in a kilometer. Meters to centimeters, times by 100. And then times by 10. Going back the other way, you got to divide. So this is a very useful way to help you convert things. So that there. And then I'm going to go into the example here. So we've got 1 centimeter to 1 kilometer. They're not in the same unit, so we're going to put them in the same units. So 1 centimeter to 1 kilometer. 1 kilometer is how many meters? 1,000 meters. Still not in the same units. How do you get from meters to centimeters? Times by 100. So 1 centimeter becomes 100,000 centimeters. So if you were to do that on your calculator, if you weren't confident, you'd go 1 and then you times it by 1,000. 1 lot of 1,000 is 1,000. And you times that by 100. And it gives you that answer. But we just had 3 zeros because we times by 1,000. When we times by 100, add another 2. So we got that there. And now they're the same. So at this point, you can get rid of the centimeters. So the scale is 1 to 100,000 there. Now I'm going to scroll down just a little bit here so I can do examples 2 and 3. Example 2. Well, I'm going to assume here from my monitor that that's 1 centimeter. So I'm going to say 1 centimeter is 2 kilometers and do the same process as before. So 1 centimeter, how many meters? Well, it's 2,000. How many centimeters is that? 200,000. So times by 100. So it's 1 to 200,000. Now I just realized I've got some equal signs going on there. But we're doing ratios here. So let's make sure, let's use this instead. It's a nicer way to do it. And example number 3, map scale, 1 to 25,000. So this is the real. The second number is the real distance. The first one's just a map. What is the actual distance? If the scale distance is 4 centimeters, you take 4 times it by 25,000, 4 centimeters, and you're going to get 100,000 centimeters. Now, let's get that into a more useful unit. Centimeters to meters, what do I got to do? I got to divide by 100. So that gives me, you can do this in your calculator if you want, and it will give you 100,000 divided by 100, and you get 1,000 centimeters, 1,000 meters, sorry, which is 1 kilometer. So 4 centimeters on the map, 1 kilometer. Okay. What is the scale distance if the actual distance is 3.5 kilometers? Well, this time instead of timesing, we go back the other way, we divide like we did yesterday. So we take the 3.5 kilometers and divide it by 25,000 because it's 25,000 times more. This I will do in a calculator because 3.5 over 25, I don't think we're going to get a nice number. It's not that bad a number. 0.000014 kilometers. But that's not very useful. So how do I get from kilometers to meters? Times by 1,000. So 0.14 meters. To get from meters to centimeters, times by another 100, 14 centimeters. So the scale distance is 14 centimeters. That'll give us 3.5 kilometers on the map. So that's it. I think I should just change this color because it's all the same color. That makes it, no, it's too thick. Where's the thin? There we go. A little bit easier to read. So the example 2 is in purple, example 3 there in red. And I will pause here, give you a chance to write that down before we go into questions. Pausing. Okie dokie. Going to scroll down here. Now we've got 2 pages of questions, and I'm just going to do some of them to get you started. So I'll just do like 1A, D, 2, just some of the ones on the left. So 2 centimeters to 200 meters. They're not in the same units. Easiest way to do it is to put them both in centimeters. So 2 centimeters, and you'd go 200 times by another 100. It means adding another 2 zeros, 20,000. 2 zeros plus another 2 gives you 4. And now we can divide by 2. 1 centimeter is 10,000 centimeters, And so it's 1 to 10,000. So get them in the same units. That's how we do actually all of them. I'm going to scroll and I'll come back to this. Oh no, I'll leave it there for a bit more. Determine the scale ratio for each of the following. 2 millimeters on a scale drawing represents an actual distance of 50 centimeters. Well, it's the same. Like, you have to write this to start. And then put them both in millimeters, times by 10, divide by 2, 1 to 250. That's the sort of thing we do. Now I'm just going to, I'll pause here, and then I'll scroll down. Okie dokie, scrolling down to 3. Just want to give you a couple of answers from this page. 1 from 3, 1 from 4. So question 3, find the actual distance. Find the actual distance for each of the following scale distances. So the scale is 1 to 10,000. The second one's the actual. So this one, you say 2. And what we have to go here is going to times by 10,000. So it's 2 centimeters times by 10,000, 20,000 centimeters. And see how it says give your answer in an appropriate unit? They want you to put that into something a bit nicer. So if I divide by 100, I'll get 200 meters. So I was using your calculator. 20,000 divided by 100. Why divide by 100? Because that's how you get from centimeters to meters. So that's how you do that. And then for question 4, find the scaled lengths for each of these actual lengths. So we're given the actual one, and we want to find the scaled one in the drawing, the map. And the drawing is 200 times smaller. So just what we do is 200 meters divided by 200, 1 meter. That sort of thing. Okay, I want you to have a go at all of those, and I'm going to give you answers to everything. Pausing. And we're all done. Now, I've zoomed down enough so you can see the entire page. I already gave you those 2 ones in purple before, so the other ones in orange are all there. Now, the one down the bottom, 2D, I put that in a different color because they tried to trick you. They put the actual length first and then the scaled one second, whereas all the other ones is in the correct order. That one they put in the wrong order there. So the scale number, the scaled length, it goes first, and the actual length goes second. All right, I'm going to scroll down, show you the other answers. This other page here, oof. I think I might have to zoom in a little bit. So there we go, other answers. If that isn't big enough, I'll zoom in. And we'll do it in 2 parts. Top part, question 3. I did answers there. The reason why I changed this scale here in orange is because I don't like seeing decimals, 1 to 0.5. So I just doubled it. So it's a scale of 2 to 1. Made life a little bit easier. But if you wanted to, you could times by 0.5. That would work too. Gives you the same answers. All right, I'm going to scroll down. In 1. And here's the answers for question 4. And again, with the last one, I chose to change it into 10 to 1, just to make my life easier. Okie dokie, gonna end it here. That's our lesson. From this point onwards, we get to go into something different. Rates. Really very, very practical rates. Ratio is good. Rates are better. Rates occur more often. All right. See you next lesson.